Hello, everybody. Our today's topic is A-level chemistry, nomenclature of benzene compounds. We know that the structural formula of benzene is this. The important evidence that benzene is a cyclic structure whenever a monosubstituted derivative of benzene is produced. If only one atom or group of atoms attached to benzene ring, it produces one product. This means that either the atom or group of atoms attached with any one carbon atom of benzene, its properties and its IUPAC name will remain the same. For example, all of these are monosubstituted derivatives of benzene. This is chlorobenzene, nitrobenzene, methylbenzene, phenol, which is also termed as aromatic alcohol. This is benzaldehyde because this is the formyl group, which is a group of aldehyde. On combination with this benzene ring, this is called as benzaldehyde. Similarly, due to the presence of this benzene along with this carboxyl group, this is called as aromatic carboxylic acid, and this is called as a benzoic acid. Now, whenever the one group attached into the benzene ring, then this carbon atom to which this group will be attached, that will be termed as number one carbon. If we start numbering, for example, now this carbon will be termed as number one. Now, from any side we can give numbering. Any side from this carbon we can number. But when second substituents come, when second group attach, for example, if second group attach here, CH3, then definitely with respect to this carbon atom, this will be the second position of methyl group. And now the numbering will be definitely start from this side, not from this side. Now numbering will become number 1, 2, 3, 4, 5 and 6 numbered carbon. Numbering will take place just like this. Similarly, from these numbering we come to know that adjacent carbon to the carbon number 1 will be number 2 from this side or from this side if only one substituent is present. If I write here just like this is OH group, then automatically we understood from this numbering that both of these are present at number 1 and 4. If we take this as a number 1, this will be present on number 4. And if this is taken as number 1, this will be present on number 4. Now, if some other group is present here, then definitely it will present at number 3 position. For example, if this carbon is number 1, this is second, this is third. Now, we can't numbering carbon atom in this side because the second substituents from this side will adopt higher number, while numbering from this side it will adopt lower number. So we will prefer that side from where the carbon containing substituent get lowest possible number. In this manner, this will be automatically called 3-chloromethylbenzene. This is the easiest naming way. But in both of these cases, these are the bulky groups. That's why these are also termed as number 1. already. Now, the second substituents might be here or might be here and also over here. Now, we have to name of this will be 2-nitro benzoic acid. 2-nitro benzoic acid, because this nitro group is attached with number 2 carbon atom. In this manner, we start numbering and give the name. Now, this compound will be numbered as, for example, 1, 2, 3, 4. It means that on third carbon there is a chloro group, 3 chloro, 4 nitro benzaldehyde, 3 chloro, 4 nitro benzaldehyde. In this manner, we name the different aromatic hydrocarbon, benzene or aromatic hydrocarbon, substituted hydrocarbon or derivatives of benzene. And this is a method to name. Now, one thing which is most important in this regard to remember, for example, if I replace the position of both of these, for example, if I put nitro here and chloro here, now I have to name this compound. This is number 1 carbon, this is second, this is third, this is fourth, fifth, and then sixth. No doubt, this nitro is present at third carbon atom and chloro is present at fourth carbon atom. But when we have to write down the name, we have to follow the alphabetical order of the substituents to mention. Now, the C for the chloro comes first, then N for nitro. That's why we will mention chloro first, then nitro, in spite of the fact that the number of carbon atom to which nitro is attached, that is 3, and the number of carbon atom to which chloro is attached, that is 4. We will not consider the numbering, either the number is larger or smaller. We have to follow the alphabetical order of the substituents to represent, and then we have to name the aromatic hydrocarbon. For example, this will be called as 4 chloro. Chloro will come first, then 3 nitro, then nitro will be mentioned, and then benzaldehyde. In this manner, we can name all aromatic hydrocarbons. Now, next is the reactions of benzene. Reactions of benzene. We know that benzene has the formula C6H6. This is its structural formula. In spite of the fact that high degree of unsaturation is present in benzene ring, but still benzene preferably perform substitution reactions rather than addition reaction. While we know that substitution reactions are the properties of saturated hydrocarbon, but benzene having a high degree unsaturation still follow the substitution or saturated hydrocarbon reactions. This shows that the benzene molecule extraordinarily stabilized. This is least reactive. Why this is least reactive? This is a cyclic ring, and pi electron system formulate a sheath of electron, and due to the revolution of all 6 pi electrons over entire benzene ring, make this molecule extraordinarily stable. No doubt, benzene give both addition and substitution reaction, but benzene gives substitution reaction more conveniently as compared to the addition reaction. For example, if we perform the reactions of benzene, just like if we add bromine water, Br, Br, will write bromine molecule just like Br2. Now, if we want to perform a chemical reaction, we have to add some electron pair acceptor into the reaction mixture so that it can formulate the bonding first, and then a very strong electrophile should be there which should be able to attract the very stable pi electron system of benzene. In this regard, for example, if we put FeBr3 in this reaction, what will happen? First of all, the reaction of both these will be takes place. This is electron pair deficient. Automatically, this will react first along with its pair of electron towards it, and it will form FeBr4 minus, leaving behind Br positive cation. It means that now this is extraordinary strong electrophile. So the pi electron system present in benzene ring that can be represented just like this. Now this strong electrophile can attract pair of electron for the bond formation. For the time being, this will formulate an intermediate just like this, and its electron system will break and a positive charge will come here, and this will produce benzenonium ion. Now we know that each carbon of benzene contains one hydrogen. Here one hydrogen is also present. Now the bond formed between carbon and bromine is stronger as compared to bond between carbon and hydrogen. That's why this electron pair scheme of benzene ring will not be remain distorted for a longer time, and automatically it will attract this pair of electron inside the benzene ring. What will happen? Whenever both of these electrons will come into the benzene ring, automatically the benzene ring will be restored again with bromine present with it. And what will it produce? It will produce H positive ion, proton. This proton will be produced. Now, in turn, at the last, this proton will react with FeBr4 minus, producing FeBr3 plus. We will get HBr. It means that FeBr3 are acting as a catalyst because it is regenerated at the end of a reaction, and it has provided a path that bromine atom is substituted in benzene ring in place of hydrogen. So this produces bromobenzene. Whole of this reaction can also be termed as halogenation. Now, this is the reaction of halogens in the presence of a suitable catalyst which is electron deficient. Now, another type of halogenation can take place. Another type of inert solvent, if benzene is treated with chlorine, then 3 molecules of chlorine in the absence of any catalyst, in the presence of that will give addition reaction, and the product will be formed as just like this HCl such type of product will be formed, and this is called as a hexachlorocyclohexane. Hexachlorocyclohexane will be formed as a result of this. Now, what will happen if a halogenation of a substituted benzene takes place? Remember the previous reaction. If we have just like this, if we have for example, if we have methyl benzene, if we treat methyl benzene with chlorine Cl2 in the presence of AlCl3, the same process will take place. This will react first with chlorine producing Cl positive, and this adduct with AlCl4 minus. Now this is a very strong electrophile. Now this electrophile now attack on this benzene, and it can produce the product just like this. Again, substitution reaction will be observed, and we will check. Product might be just like this. Again, if we treat next step, product might be just like this, and in the third step the product might be just like this. What will be the product? This will take place in 3 steps, and the name of this compound will be, if this is number 1 carbon, then 2, 4 and 6, 2, 4, 6 trichloromethylbenzene. 2, 4, 6. Why 2, 4? Because if this is number 1, this is number 2, this is 3, this is 4, this is 5th, and this is 6th carbon atom. The answer will be 2, 4, 6 trichloromethylbenzene. This will be the product if we treat methyl benzene with chlorine in the presence of a catalyst HCl3, which is electron acceptor. But if we change the condition, if we don't add this electron pair acceptor, then product will also change. What will happen now? Here the reaction will behave differently. Now, if we only provide radiant energy, now benzene ring due to its stability will remain safe, and the substitution reaction will take place on the side chain. At the first step, we will get this reaction, this product plus HCl. If the process continues, we will get this product CHCl2 plus HCl. And if still this process continues, we will get this product CCl3 plus HCl. This is called as benzyl chloride. This is called as benzyl chloride. This is called as benzo chloride. Now, it means that whenever we will change the condition, the mechanism and product of the reaction will be changed. All these examples, these shows that benzene easily undergo substitution reaction. Now, what is the name of this substitution reaction? For example, if we react benzene in the presence of a catalyst, a very strong electrophile will produce that will snatch pi electron from the benzene. That's why substitution reaction will take place, and the name of reaction will be electrophilic substitution reaction. Electrophilic. Why? Because the reaction is initiated by the pi electrons present on the benzene ring. That's why this is termed as electrophilic substitution reaction. Now, another substitution reaction is nitration of benzene. Nitration of benzene. For example, this is benzene. We react this with concentrated HNO3. Concentrated HNO3 along with in the presence of concentrated sulfuric acid. What happens? What happens first? First of all, both of these acids, HNO3 plus H2SO4, both reacts together and produce what? NO2 positive plus H2O water and plus HSO4 negative hydrogen sulfate. These are produced, but as hydrogen sulfate contains negative charge, that's why this will not be attracted by the pi electron, or it will not can attract the pi electron of the benzene due to the similar charges. Only the electrophile produced is NO2 group. NO2 group is a strong electrophile produced which will now react with this benzene, and the reaction will take place in the similar manner just like I have already explained. This is NO2, NO2 positive. Now, pi electron of benzene that will be attracted by this nitro group, and this will produce an intermediate just like NO2 along with H with positive charge. Now, as I have explained that the bond between nitro and carbon is very strong, but bond between carbon and hydrogen is very weak. So, pair of electron will taken inside the benzene, and we will get again the product, this. This will be called as a nitrobenzene with H positive ion. Now, this H positive ion at the end will react with HSO4 negative ion, producing sulfuric acid again. It means that in this whole reaction, sulfuric acid acts as a catalyst which is regenerated at the end. This is called as a nitration of benzene. Now, in the similar, if we perform the nitration of, if we perform the same reaction of methyl benzene, if we perform the same reaction of methyl benzene at an elevated temperature nearly equal to 100 degrees centigrade, what will happen? At the 3 position, 2nd, 4 and 6, this nitration can take place, and as a result we will get product. This product. Now, this is called as 2,4,6. 2,4,6 trinitro toluene. This is a common name or methyl benzene. This is commonly called TNT, which is used as an explosive material. Trinitrotoluene. This is produced by the nitration of methyl benzene, and the reaction is again electrophilic substitution reaction. In this manner, benzene perform quite easily substitution reaction against the addition reactions. I have explained some of the facts of the chemical reaction of benzene with different reagents. Hope you understand all these concepts. Please like, share, subscribe and comments on my videos. I thank you all.